Good morning, good afternoon, and good evening. This is Mr. Payne bringing you arithmetic sequences. There are many types of sequences, but there is one that is related to linear functions and in fact is type of discrete linear function. They are known as arithmetic sequences. So arithmetic sequences go with the word linear functions, making sure that you understand that these functions that we're dealing with will create a linear line. Let's look at A. It says fill out the table below an amount of money Evan has after n weeks of saving. So Evan is saving money to buy a new toy. She already has $12 in her account. She starts with $12. She gets an allowance of $4 per week and plans to save $3 in her account. So if I have 12 and after the first week I add 3, that means I'm at $15. And I add 3 to that, it's 18. I add 3 to that, it's 21. $24 after week 4, $27, $30, and $33. B says, write a recursive definition for the sequence. And we've already been working on this, so A sub 1, I would like you to actually hit pause. Try to do it on your own first. A sub 1 equals 15, and A sub n equals A sub n minus 1. That's my recursive part, don't forget. Plus 3. Don't forget, I got plus 3 for my pattern of plus 3 here. That's where I got the plus 3 from. Now I want us to do a little critical thinking. Evan proposes that the following explicit formula is this formula correct? Okay, and this is the first time we've talked about the explicit formula. We're going to get used to writing these in a minute. So the explicit formula is 3 times n plus 15. Well, let's try it out. If I take n, which is, let's take 1, 3 times 1 plus 15. 3 plus 15 gives me 18. Is that what I have for n? Is that what I have for my first term? No, it is not. So this does not work. This formula is not correct. What should it be? Well, if I use this 3n still, if I say 3 times 1, okay, well, 3 too many, so let's take 3 away from the 15, so that would give me 12. So the correct explicit formula would be 3n plus 12. Now I'm going to show you how we came up with that in a moment. Let's look at exercise 2. An arithmetic sequence is given using the recursive definition. B sub 1 equals negative 3, and B sub I equals B sub I minus 1 plus 6. This I is no different than saying B sub n, so don't get confused. Right away, what I do, and you know how to do, this is review from the night before, write down my terms. It says that we're looking for the value of B sub 4. So B sub 1 is negative 3. Now I just go ahead and plug in my recursive formula and do it as many times as it takes to get to B sub 4. So B sub 2 equals B sub 2 minus 1 plus 6. B sub 2 minus 1 is B sub 1. B sub 1 is negative 3. Negative 3 plus 6 is giving me 3. So B sub 2 equals 3. Don't get confused with this section right here. I just combined a couple steps. I just didn't write down B sub 1. And B sub 1 is negative 3. Okay? Let's look for 3 now. So B sub 3 equals B sub 3 minus 1 plus 6. This is B sub 2 plus 6. B sub 2 is 3. 3 plus 6 is going to give me 9. B sub 3 equals 9. And let's do it one more time for b sub 4. b sub 4 equals b sub 4 minus 1 plus 6. b sub 4 is b sub 3. b sub 3 is 9 plus 6. 9 plus 6, b sub 4 equals 15. The fourth term is 15, so that would be choice 4. Arithmetic sequences are relatively easy to spot and are easy to fill in. You did a wonderful job with this on Tuesday, so let's continue that work. For each of the following sequences, determine if it is arithmetic based. Well, how do I know if something's arithmetic based? Well, if it is adding or a subtracting pattern, that is the arithmetic base. If it is arithmetic, fill in the missing blank. If it is not, show why. So let's look at A. 5 to 9. How do I go there? Then to 13. Well, the pattern is add 4. Is that arithmetic? Well, I said if it's adding or subtracting, so therefore it is. 13 plus 4 gives me 17. That is arithmetic. B. How did I get from 5 to 10, and then from 10 to 20, and then 20 to 4? Well, I multiplied by 2. 40 times 2 is going to give me 80. This is not arithmetic. This is geometric. C. How did I go from 7 to 4 to 1? Well, if you said subtracted by 3, you would be correct. 1 minus 3 is going to give me a negative 2. This is arithmetic. Let's look at D. 64 to 16, 16 to 4. How did I do that? Well, let's think about the 16 to 4. I think I could divide by 4, and that gets me my pattern. What is 4 divided by 4? 4 is 1. And I said that arithmetic is only when I'm adding and subtracting, so this is not arithmetic. That is also geometric. For arithmetic, I want you to learn that there is an arithmetic formula, and I'm going to show it to you right now real quick. Your arithmetic formula is a sub n equals a sub 1 plus n minus 1 times d. Your d being the difference in the change in your pattern. Your a sub 1 is your first term. Your n is your term. So let's look at A and let's put this to work real quick. A sub n, I'm going to look for 2. So I'm going to look for a sub 2, which equals a sub 1, which is 5, plus 2 minus 1 times d. My d is going to give me 4. That's my pattern change. 2 minus 1 is 1 times 4 plus 5. A sub 2, 4 times 1 is 4, plus 5 gives me 9. A sub 2 is 9. Is a sub 2 9? Yes, it is. So therefore, that's how that formula, the arithmetic formula, works. Exercise number 4. Consider an arithmetic sequence whose first terms are given by 4, 14, and 24. What I did right away was I tried to figure out what is my pattern. My pattern is, well, in the first one I went up by 10. Then I added 10 from 14 to 24. So my pattern must be plus 10. So 24 plus 10 is going to give me 34. 34 plus 10 is going to give me 44. What is the fourth term? How many times was 10 added to 4 to get to the fourth term? Show a diagram to illustrate this. Well, we figured out that the fourth term was 34. And if I want to add, how many times did I have to add to get to the fourth term? I had to add it 3 times. B. Use what you learned in part A to find the value of a sub 10, or the 10th term. Well, what I'm going to do is this. I would like you to go ahead and continue the pattern up top there until you get all the way out to the 10th term. Hit pause and do that now. Okay, you should have it worked all the way out to the 10th term. Now, and have this answer. What I'm going to show you is how to use the explicit formula to go ahead and set up and find out what the 10th term is. A sub n equals a sub 1 plus n minus 1 times d. Now I explained to you earlier in the video how to plug everything in. It's my 10th term, so it's a sub 10 equals a sub 1 plus, in parentheses now, 10 minus 1 times d. And I'm just going to back up real quick. That's not, the d is going to give me my plus 10, because that's my change, so it's positive 10 times 10. A sub 1 is 4, so I'm going to put a 4 in there instead of a sub 1. Now let's do the math. 10 minus 1 is 9. 9 times 10 is 90. Plus 4. A sub 10 equals 94. Did your answer match my answer? Now let's go ahead and write down the recursive formula. I'm going to do the recursive formula in orange. A sub 1 equals 4. And a sub n equals a sub n minus 1 plus 10. That's the recursive formula. The explicit formula is using the formula from up above right here and just simplifying it down. What is the explicit formula then? Here's the explicit formula. Let me show it to you. It's a sub n equals a sub 1 plus n minus 1 times the d power, or times the d. So a sub 1 is going to give me 4. I don't know what term I'm looking for, so it's just going to stay n minus 1, and it's going to give me 10. I'm going to now multiply the 10 in. It's going to give me 4 plus 10n minus 10. 4 minus 10 is going to give me negative 6. So my recursive formula is going to be a sub n, or my explicit formula is a sub n equals 10n minus 6. And let's see if that works. 10n, 10 times 1, if I'm looking for the first term right up here, I'm going to take the first term. So 10 times 1 is 10, minus 6 gives me 4. Does that work? Yep. 10 times 2, my second term, gives me 20, minus 6 gives me 14. Yep, that works. So this is the explicit formula, 10n minus 6. A sub n equals 10n minus 6. And I got that by deriving from the arithmetic formula of a sub n equals a sub 1 plus n minus 10 times d.